Alright, so I promised you some example problems. I just pulled these straight out of your book. They're actually right at the end of chapter 8. I don't remember off the top of my head, though, what number it is. So, first off, let me get a pen. I'm gonna go. Okay, aluminum reacts with oxygen to form aluminum oxide. I remember I told you I'm not a fan of the word problem, but if you are, then great, you can write out the word equation. I'm just going to underline. So aluminum reacts with oxygen, so reacts with is our plus sign, to form is our arrow, aluminum oxide. Now they don't mention water in any of this, so I'm going to assume that none of this is going to be aqueous. The other thing that you can safely assume is that unless you're told otherwise, all of these reactions happen at room temperature. So at room temperature, aluminum is a solid. Oxygen, remember, is Brinkelhoff, so it's O2, and at room temperature, oxygen, thankfully, is a gas. And it's going to react to form aluminum oxide. Now, aluminum oxide is an ionic compound, which means it's a solid, but to come up with the correct formula for it, you need to know the oxidation number for aluminum, which is +3, and oxygen, which is -2. Look at your periodic table if you've forgotten how to find those. And do your little crisscross to come up with the formula of Al2O3 solid. Now, of course, we have to balance this. I got 1 aluminum, I got 2 aluminum, so I'm going to put 2 right here. And then looking at my oxygens, I've got 2 here and I've got 3 here. Well, in order to balance these out, I'm going to use something called the least common multiple. If you remember that from your math class, the least common multiple between 2 and 3 is 6. So what do you have to do to 2 to get it to be a 6? Well, you got to multiply it by 3. What do you have to do to 3 to get it to be a 6? Well, you got to multiply it by 2, which then just changed my number of aluminums to 2 times 2, which is 4. So cross that guy out and make a 4. So there's your final reaction. Phosphoric acid is produced through the reaction between tetraphosphorus deck oxide and water. So phosphoric acid is actually our product because it says is produced through the reaction between tetraphosphorus deck oxide and water. So tetraphosphorus, tetra means 4, phosphorus is P, so we have P4. Deck oxide, deck is 10, oxide is O, so P4O10. And we're going to add to it some water. We can assume that this is a solid because we're at room temperature. Plus water. Water is H2O, and at room temperature is a liquid. So basically we're just mixing these two compounds. And when you mix it, you get my favorite, phosphoric acid. Remember, phosphoric, the ic comes from the 8, phosphate, polyatomic ion. Phosphate is PO4 with a -3 charge, so to balance that out, you need 3 hydrogens. And because we have now thrown water into the mix, and this is an acid, this is, of course, aqueous. So now we got to balance this thing, and this is going to be a messy balance. Let's see here. We need 4 phosphoruses. We only have 1, so I'm going to put a 4 right there. That gives me, I'll move on to my oxygens next. So I have 10, 11 oxygens over here. I have 4 times 4 is 16 oxygens. Well, I don't want to do anything with this because I've already balanced out my phosphoruses. So, since I need 16, I got 10 here. What if I put a 6 right there? That gives me 10 plus 6 is 16 oxygens. And then let's check my hydrogens. 6 times 2 is 12. 4 times 3 is 12. So, they balanced each other out on their own. Don't you love it when that happens? Okay, next up. Iron 3 oxide, also known as rust, reacts with carbon monoxide to produce iron and carbon dioxide. So first up, formula for iron 3 oxide. This would be iron with a +3. Oxygen has a -2. So crisscross those guys and you end up with Fe2O3. And again, no mention of water, so I'm going to say that this is a solid. Adding to that, carbon monoxide, which means CO, and carbon monoxide at room temperature is a gas. You should know that from experience. To produce iron, so I'm going to say that's going to be solid iron, and carbon dioxide, which is CO2, also a gas. So to balance this out, start with your metal. So I have 2 irons, I have 1 iron, so let's plop 2 out there. And then I have 3, 4 carbons, and I only have, or I'm sorry, I should have started with carbons. Got 1 carbon, 1 carbon, I got 3, 4 oxygens, I only have 2, so if I put a 2 there, that gives me 4 oxygens and 2 carbons, and then I gotta put a 2 there. Ooh, that just kind of jacks things up. Something else must be getting produced here because this guy is not balancing. I'll look over this, post up a new video later, so we'll come back to this one. Alright, last one, butane gas. And I gave you the formula because I do not expect you to know the formulas for hydrocarbons. So C4H10 gas is burned in the presence of oxygen. Oxygen is a gas, thankfully. It's also Brinkelhoff, which is why we put O2 instead of O, to produce water, which would be a liquid at room temperature, and CO2, which is a gas. Balance this guy out. We're going to start with our carbons. We have 4 carbons here. We got 1 here. I'm going to plop a 4 out front. I'll move on to my hydrogens next. I got 10 hydrogens. I got 2. So I'm going to put a 5 right there. Now with my oxygens, I got 2 oxygens on this side. I have 5 oxygens here, plus 8 here for a total of 13 oxygens. Well, to get a 2 to become a 13, you would need to multiply it by 6.5, which of course we can't do, but what we can do is now take this whole thing, well, that's kind of supposed to go there, and multiply this whole thing by 2, so that we end up with 2, whoopsie daisy, sorry about that, C4, did it again, H10 plus 13O2 gives way to 10, crying out loud, 10 waters, and 4 times 2 is 8 CO2s. And that, ladies and gents, is it. If you have any questions over the weekend or anything, just send me an email, and I'm sure I'll check my email periodically throughout the weekend if we don't have school tomorrow. And if we do, then y'all be good for Mr. J, and I'll see you on Tuesday anyways. And with that, I will say, if I can get my thing, adios.